Hey guys, welcome back. So in this video, we're going to be reviewing the solutions to the practice problems given in the previous video. So if you haven't already, please do these practice problems. Before you look at this video, please try to do them yourself, and whether you understand them or don't understand them, please look at the solutions video. If you do understand the problems, I still think more exposure to math will be really great for you, and if you didn't understand it, well, that's completely fine. That's what we're here for, so let's just review this. Okay, so let's do the first problem. So the first problem is 2 over 3 times negative 5 over 6. Okay, so there's basically two things that we can do here. Remember in the video I taught about multiplication, you can either multiply the numerator and numerator together and the denominator together and get the fraction, and if it does need to be reduced, then reduce it. Or you can do cancellation and then multiply the numerator and denominator. So I'm looking at these two fractions, 2 over 3 times negative 5 over 6. Okay, so what I see here is that 2 and 6, so right here, 2 and 6, they're multiples of 2. So what I can do is that I can cancel the 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So then I have the fraction rewritten as 1 over 3 times negative 5 over 3. Now notice I can't cancel this 3 and this 3 because they're both in the denominator. If the 3 was in the numerator and there was a 3 in the denominator, I could cancel them. But since both the 3's are in the denominator, I can't. So what I'll have to do is I have to multiply it straight through to get 1 times negative 5, which is negative 5, and 3 times 3, which is 9. So I get negative 5 over 9 as the answer. Now let's try doing it, just multiplying it straight across. No cancellation, nothing. So this is still the same problem. So if I do have 2 over 3 times negative 5 over 6. Okay, so no cancellation, I just multiply it straight. Numerator and numerator get multiplied, and denominator get multiplied. So 2 times negative 5 is negative 10, and 3 times 6 is 18. So I get negative 10 over 18. This can be reduced. So since 10 and 18 are factors or are multiples of 2, you can cancel these two. So you'll get negative 10 divided by 2 is negative 5. And then 18 divided by 2 is 9. So guess what? You get the same answer. So you get negative 5 over 9. So you do either the cancellation method or you do just multiplying straight through method. Either way, if you are very careful, very diligent, you will get to the right answer. Number 2. 6 over 10 times 2 over fifths. So some of you may be noticing that some things can be canceled. If you're not, that's completely fine. If you don't notice that things can be canceled, just multiply it straight through. So you get numerator times numerator, so 6 times 2, which equals 12. And you get denominator times denominator, and the two denominators are 10 and 5, so 10 times 5 is 50. So 12 over 50 can actually be reduced. So whenever you get the solution, even if you did cancel, just double check to see if the solution fraction can be more simplified. So you have 12 over 50. That can be simplified because 12 and 50 are both multiples of 2. So 12 divided by 2 is 6, and 50 divided by 2 is 25. So you'll get the answer 6 over 25. Now, let's try the cancellation method. So still the same problem. You have 6 over 10 times 2 over 5. So what you may notice here is that 6 and 10 are both multiples of 2, 2 and 10 are both multiples of 2. Notice that in the denominator you have 10 and 5. You might be saying, oh, well, 5 and 10 are multiples of 5, so can't they cancel? No. If the numbers are in the numerator, they can't cancel with each other. If both the numbers are in the denominator, they can't cancel with each other. Only the numerator and denominator of different numbers, when multiplying fractions, can cancel. So you can do it either way. You can cancel 6 and 10, or you can cancel 2 and 10. I'm just going to cancel 6 and 10. So 6 divided by 2 is 3, and 10 divided by 2 is 5. So what you get 3 over 5 times 2 over 5. So now you just multiply numerator and numerator together, and denominator together. So you get 3 times 2, because they're both in the numerator, and then you get 6. And then 5 times 5, since both the numbers are in the denominator, and you get 25. So you get the same answer either way. And still, just double check. Can I simplify 6 over 25? So once you've double checked you can't, that's your answer. Please do remember that a lot of people count, if you get the answer as we got before, for example, 12 over 50, if you got that and the fraction can be reduced, but you didn't reduce it, it's still technically wrong. So we really want you to reduce the fractions. Cancellation's a pretty, I think once you get the hang of it, it can be an easier technique to use rather than just simplifying the solution. But for now, whatever feels comfortable, but I also want you to practice both ways, preferably cancellation. Okay, let's do the next one. And I do want to clarify that the word cancellation is, I just want to clarify that's kind of like a word I made up in math, because there's no exact term exactly for canceling the numerator and denominator numbers. This is just a term that I refer to make things easier, rather than saying cancel the numerator and denominator, I just say use the cancellation method, basically. It's like that's not the right term for it, because there is no term for it, but in these videos I will be referring to that, especially for multiplication problems. So let's do the third one, which is 4 over 5 times 1 over 4 times 3 over 6 times 10 over 20. Okay, so yes, you can multiply all the numerators and all the denominators together, but in this case, that wouldn't be the best idea, because I can see there's a lot of things that can get canceled. So let's walk through it. So I look at 4 over 5 individually. 4 and 5 can't get canceled individually. They're not like multiples of the same number, besides 1, but that doesn't help here. 1 over 4, which is the next fraction, 1 and 4 can't get canceled. So I go to the next fraction, 3 over 6. 3 over 6 can in fact cancel because 3 and 6 are both multiples of 3. So I do 3 divided by 3, which is 1, and I do 6 divided by 3, which is 2. Now I go to the next fraction, which is 10 over 20. 10 over 20 can indeed cancel. So let's say you didn't notice that 10 and 20 are factors of 10, or are multiples of 10, but you do notice that they're multiples of 2. That works as well. So what you do 10 divided by 2, which is 5, and 20 divided by 2, which is 10. Now, you may notice that 5 and 10 can also be canceled, because 5 and 10 are both multiples of 5. So you do 5 divided by 5, which is 1, and 10 divided by 5, which is 2. Notice that when you do 10 divided by 20, and you do realize that 10 and 20 are multiples of 10, and if you cancel 10 and 20 with 10, so if you do 10 divided by 10 is 1, and 20 divided by 10 is 2, you get the same answer, which is 1 over 2. But we're still exactly not done yet. So we have 4 over 5 times 1 over 4 times 1 over 2 times 1 over 2. There is one more thing that can be canceled. So before, we were looking at the fractions individually and seeing what could be canceled individually within the fraction. Like I was looking at 3 over 6, and I'm like, oh, the 3 and 6 can cancel. And I was looking at 10 over 20, I'm like, oh, the 10 and 20 can cancel. But I wasn't looking in between the fractions just yet. So, for example, if I look at 4 over 5 and 1 over 4, 4 over 5 times 1 over 4, that can cancel because the 4 is in the numerator and there's another 4 in the denominator. Even though it's in a different fraction, it's still the same thing. So the 4 and 4 can cancel, so 4 divided by 4 is 1, and 4 divided by 4 is 1. So I get 1 over fifths times 1 over 1 times 1 half times 1 half. So now I can't cancel anything, so what do? I multiply all the numerators and all the denominators together. So in the numerator, I have 1 times 1 times 1 times 1, which is 1. And in the denominator, I have 5 times 1 times 2 times 2. 5 times 1 is 5, 5 times 2 is 10, and 10 times 2 is 20. So I get 1 over 20, which is my answer. So please double check, even if you did do cancellation, there could be a possibility that you might have missed a number or, something like that. So please check if the solution can be reduced, even if you did do cancellation. So over here, it's 1 over 20, so that can't be reduced. But just in the future, even if you do cancellation, just double check, because you might have missed a couple numbers, and then the fraction might not be reduced, and that's technically wrong. So let's do last problem together. Okay, so last problem, number 4. 10 over 30 times 2 times negative 4 over 12ths. Okay, so before we do anything, before we multiply anything, before we cancel anything, I'm going to rewrite this as 10 over 30 times 2 over 1. Remember, 2 does equal 2 over 1, because 2 divided by 1 is still 2, times negative 4 over 12ths. Okay, so all I did here from step 1 to step 2 was change 2, just 2, to 2 over 1. Now, this may be a little easier to cancel because now it's very clear what the numerators are and it's very clear what the denominators are. So let's see if we can cancel stuff. So let's look at the first fraction, which is 10 over 30. So 10 and 30 are both multiples of 10. So you do 10 divided by 10, which is 1, and 30 divided by 10, which is 3. Then you look at 2 over 1. 2 over 1, the only multiple that 1 and 2 have in common is 1, which doesn't really help us to cancel. So let's look at the next fraction, negative 4 over 12ths. What are 4 and 12 multiples of? The answer is 4. It can be 2 as well if you don't exactly remember that they're multiples of 4, but they're multiples of 2, you can still cancel. And then you get 2 over 6, and then you may also realize that 2 over 6 are multiples of 2, and then you cancel those two to get 1/3. But over here, let's say we do recognize that 4 over 12 is that 4 and 12 are multiples of 4. So then you do 4 divided by 4, which is 1, and you do 12 divided by 4, which is 3. So we get 1 over 3 times 2 over 1 times, don't forget the negative, times negative 1 over 3. So now it makes it easier for us because we just have to multiply the numerators together and the denominators together. So we get 1 times 2 times negative 1. So 1 times 2 is 2, and 2 times negative 1 is negative 2. Remember, a positive number times a negative number is a negative number. Now let's look at the denominator. We have 3, 1, and 3. So 3 times 1 times 3. So 3 times 1 is 3, and then 3 times 3 is 9. So we get negative 2 over 9s. And please, even if you did use the cancellation, double check your answer, double check to see if it's in full reduced form over here we can see that negative 2 over 9 is reduced because 2 and 9 don't have, 2 and 9 are only multiples of 1, and 1 doesn't really help us. So negative 2 over 9 is the correct answer. I hope you found this video helpful. If you're still having a little trouble with it, then I would suggest revisit the multiplication tutorial. If you like this video, please subscribe to the YouTube channel. And yeah, thank you so much for watching.